I forgot to mention one very important, actually essential steps in this proof, which is that when we put the numbers in a list, we follow a certain rule, which is we call diagonal. So it starts from the first row of first columns, which is 1/1, and because the diagonal, if it goes from like upright to down to left, there's no numbers there, so that's all for the first one. And then we move to the first row, the second column, which is 2/1, and then go diagonal, which is 1/2. So you can see that the third element of this list is 1/2. Okay, and then we move to the first row of third column, which is 3/1, and then once again we go to diagonal, which is the elements following it is 2/2, and then it's 1/3, and then we just repeat the process. So then we should put it 4/1, 3/2, 2/3, and 1/4. So that's how we construct the list here. Okay. Right. Okay, let's continue. So then I'm going to introduce the sequence. A sequence is enumerated collections of objects which repetitions are allowed and orders matters. Okay. So usually we will put it this way. You can see it from that, but I will write it out here as well. So this is an example of a sequence. It will contain infinite elements of it, and we usually write it this way, or even more simpler, sometimes people will just put it this way. Yeah. Okay. And this is an example, 1/n, and as you can see that this sequence the elements will keep decreasing and goes to 0. I'm going to talk about the convergence, the concept of convergence in the later topic. But for now, you can like easily see that the number keeps shrinking and goes to zeros here. Okay. And also we can, as I mentioned, the repetitions are allowed. So you can also have a sequence like this one. Put it here. An equals to -1 to the power of n, and n is the natural number. So like in this sequence, it contains -1, 1, -1, 1, and keeps going on. Okay, so that is also a valid sequence here. Okay. Okay. And how about the subsequence? Okay. Can I erase it? should be okay, right? Okay, so to talk about the subsequence, we have to have the sequence first. So this is the previous sequence we used. It's 1 over n, and this is the first element A1, which is 1, and the second element A2 is 1 over 2. The third element is 1 over 3. Okay, and etc. etc. Keep continuing. Then it's the subsequence, which I will use the ki as index numbers here, and I start from 1 to infinity. Okay, so what is if we define the subsequence this way? So it's like we take part of the sequence, part of the original sequence, and make it into another sequence. Okay, so this is the first element, AK1, the second element AK2, and third element AK3, and it corresponded to the original sequence A2, A4, and A6. So what are those numbers? So if we put it down in numbers, it will equals to 1 over 2, and the fourth one will be 1 over 4 and 1 over 6, etc. etc. Okay. So of course, this is not the only way to construct your subsequence. It can be you can construct it in a very random way. Okay, but just notice that the order, you cannot mess up the orders. It has to follow the original order, which means that you cannot construct a weird subsequence, which is like A4 first and then A2. Okay, so this is not allowed. You have to start from the smaller numbers. Okay, so that's the only way you should pay attention to. Only thing you should pay attention to when you construct your subsequence. Okay, because the order matters here. Okay. Okay, so that is what I mentioned in the examples. Any questions? No? Right. Okay, then is just some like concept I want to introduce here. It's called supremum and infiniment. Yeah. Hopefully I didn't pronounce it wrong. Okay, so what is this two concept means? It means that supremum means that the supremum of the set X is the least upper bound of it, which we denote as sub S. Okay, so let me draw a graph here.